Imagine an artifact just steeped in millennia of history, an object that's captivated the world for, well, centuries, believed by many to bear an imprint of profound significance.
Absolutely profound.
Now imagine its authenticity, the whole question, hinged on a single scientific test. Just one.
Hmm.
And the results of that test, they send shockwaves, around the globe.
Oh, definitely. And ignited decades of fierce, really passionate debate.
Exactly. That's the story we're diving into today. The fascinating and, let's be honest, deeply controversial radiocarbon dating of the Shroud of Turin.
It's a truly remarkable narrative. It weaves together science, history, faith, deeply held beliefs. It's all in there.
And you've asked us to take a really close look at the events surrounding that 1988 dating. An event that, for many people at the time, seemed like it would finally offer the definitive answer.
The final word, yeah. That was the hope, or maybe the expectation.
Right. So our mission in this deep dive is to guide you through the intricate layers of this material. We want to extract the most important nuggets of knowledge and really help you understand why, even decades later, the story of the Shroud's dating just keeps evolving.
It does, and it keeps raising these critical questions. Questions about scientific methodology, about the pursuit of truth itself, and, how complex data gets interpreted or misinterpreted.
So as we embark on this journey, this look into the Shroud's radiocarbon riddle, what aspects jump out at you right from the start?
Well, I think the context is just vital. We can't just jump straight to 1988.
Agreed. To truly grasp the significance of that 1988 dating, we absolutely need to set the stage. We need to delve into the scientific landscape of the, say, early 1980s.
Exactly, because by that point, the Shroud of Turin research project, STURP, as everyone knows it, had already done some incredible work. Truly groundbreaking stuff.
Their 1978 studies were exhaustive, weren't they? A whole battery of sophisticated tests.
Oh, absolutely. And meticulously documented, published in serious peer-reviewed journals. These weren't fringe studies. They were getting noticed.
Globally known, really. Shaping perception, both in the scientific community and, among the public.
And that context is crucial. STURP's work was robust. It was multidisciplinary: chemistry, optics, photography, textile science, you name it. They were using the best tech available then.
And their findings were building the strong, I'd say compelling impression that the Shroud's authenticity was highly probable. That was their term, right?
Highly probable, yes. And that wasn't just a guess. It was a carefully considered conclusion based on a huge amount of empirical data. So you can see why, for many scientists and the public, the next logical steps seemed obvious.
Radiocarbon dating.
Radiocarbon dating. It felt like the key to either confirming or finally refuting that probability.
And for good reason. C14 dating is a fundamental tool. It's a cornerstone of archaeology, historical research.
It really is. But before we dive into the, let's say, drama surrounding its application to the Shroud, maybe we should just quickly unpack the core principle.
Good idea. Understanding the basic science is, well, indispensable if you want to appreciate the nuances of the debate that followed.
Precisely. So, at its heart, radiocarbon dating measures the leftover amount of a specific radioactive carbon isotope, carbon-14 or C14. It's in an organic sample.
And it's naturally occurring.
Yes, C14 is constantly being made up in the atmosphere. What makes it so useful for dating is its decay rate. It's incredibly predictable. It has a half-life of roughly 5,730 years.
Meaning half of it disappears every 5,730 years.
Basically, yes. After 5,730 years, half the C14 in a sample decays. After another 5,730 years, half of what's left decays, and so on, like a clock slowly winding down.
And this predictable decay, it's tied into the whole global carbon cycle, isn't it? Like plants breathing it in.
Exactly. Plants, like the flax the Shroud's linen is made from, are constantly exchanging carbon with the air around them. They take in CO2, which has all the carbon isotopes C14, the stable C12, C13 through photosynthesis, their whole lives.
Right. So the clock, the C14 dating clock, only starts ticking when the plant dies.
That's the crucial point. When the flax plant was harvested, cut off from the biosphere, it stopped taking in new carbon. From that moment on, its C14 content just started to decrease, decaying away at that predictable rate compared to the stable C12 and C13.
So you measure the ratio of what's left, C14 versus C12, C13.
Precisely. By measuring that ratio, the method assumes you can estimate the age pretty closely. It's elegant, powerful science, provided, and this is key, provided its assumptions hold true for the sample you're testing.
Okay, so we have STURP's work pointing towards authenticity, and we have this powerful C14 dating tool. It seems natural that STURP would see C14 as the next step.
It was definitely on their radar. But, and this is absolutely critical to understand, STURP's vision for the next phase of research was much, much broader than just getting a C14 date.
It wasn't just about the date then.
Not at all. As early as 1981, they'd formed a C14 committee, sure, but that was just one piece of a much larger, comprehensive, next best step vision. They wanted an integrated project.
Integrated, meaning combining different kinds of tests.
Exactly, a synergistic approach. They envisioned a whole suite of additional investigations running alongside, or even before, the C14 dating.
Like what kind of things?
Oh, infrared spectroscopy, advanced radiography, detailed analysis of microbiological contamination like mold or bacteria, and precise isotope ratio measurements even beyond C14.
So the idea was to get a more complete picture.
Yes, and crucially, to use these other studies to contextualize the C14 results. For example, using microscopy and chemical tests to pick the best possible sample spots that were truly representative and, hopefully, free from contamination.
That makes sense. Ensure you're dating the right thing.
Precisely. They wanted greater analytical precision in selecting the samples.
And they tried to bring other labs into this bigger vision.
They did. STURP reached out to radiocarbon labs worldwide, inviting them to join this integrated plan, and the initial response was apparently very positive, strong interest from the C14 community itself.
Leading to collaboration.
Well, initially, yes. 5 labs were invited to help prepare a new, comprehensive STURP proposal based on this integrated, interdisciplinary approach.
And this led to the 1984 STURP proposal, which sounds like quite a document.
It was substantial, 177 pages detailing 26 new scientific studies, all submitted to the custodians in Turin. And importantly, C14 testing was just one of those 26, not the main event, just part of the package.
And did this proposal mention the contamination issue?
It did. Critically buried in the section on C14, there was an early but quite clear warning. Based on STURP's own 1978 work, the proposal started that contamination must be considered as being spatially non-uniform over the entire shroud.
Spatially non-uniform, meaning patchy, different in different places.
Exactly. Not evenly spread, which is a huge challenge for dating if you think about it. Acknowledging the complex reality of old textiles.
And that awareness, that patchiness, led to a specific recommendation about sampling.
It absolutely did. The proposal specifically recommended taking at least 3 samples from 3 different locations on the cloth. And these locations needed to be carefully pre-analyzed.
Pre-analyzed how?
Using some of those other techniques they proposed, microscopy, chemistry, to make sure the spots were as representative and clean as possible before cutting.
Smart. And they also wanted a control sample.
Yes, a sample from the Holland backing cloth. That's the piece sewn onto the back of the shroud in 1534 after a fire. It would act as a known age control.
So overall, a very cautious, comprehensive, multidisciplinary plan.
That really was the STURP philosophy right there. Thorough, integrated, cautious.
Okay, now here's where the story takes a sharp turn. Because what happened next was apparently so impactful it led to books, papers, commentaries.
It's a pivotal moment, and frankly, a somewhat troubling one for the scientific process here.
What happened?
Well, those very radiocarbon labs, the ones who'd initially shown strong interest in STURP's integrated plan, they started a campaign.
A campaign for what?
To separate themselves from STURP's plan. They wanted to ditch the integrated approach and substitute it with a separate, standalone radiocarbon dating project. Just C14, nothing else alongside it.
And this wasn't just about simplifying things. Our source says they actively tried to exclude the STURP scientists.
That's the really crucial part. The C14 scientists campaigned to make sure another team of multidisciplinary scientists, who at that time were the most knowledgeable in the world on the subject of the shroud, would be eliminated from participation.
Wow, that seems pointed. And it goes completely against the STURP ethos you described.
It absolutely does. STURP was all about multidisciplinary teams tackling complex problems together, and rigor internal peer review, then external peer review, through journals.
Whereas a standalone C14 project
would mean the participating labs would essentially peer review themselves, which, raises flags about independent oversight and potential biases.
So why? Why push so hard for this standalone test and exclude the world's leading experts on the artifact itself? The physicist leading the charge, Harry Gove, offered a reason.
He did. Harry Gove, a respected physicist, a pioneer of the AMS dating method, which was key here.
AMS, accelerator mass spectrometry, the one that needs tiny samples.
Exactly. Very relevant for the shroud. Anyway, Gove later justified his behind-the-scenes maneuvering, as the source puts it.
What did he say?
His stated reason was quite blunt. He said, and I'm quoting, "I believed STURP's members to be so convinced it was Christ's shroud that I was determined to prevent their involvement. I fear the most important measurement would be rendered less credible by their participation. Fortunately, in this, I was successful."
So he thought they were biased, that their belief would compromise the science.
That seems to be his stated concern, perceived partisanship tainting the result.
But our source pushes back on that, right? Points out the diversity within STURP.
It does, and it's a vital counterpoint. The source highlights that STURP fielded a proven team of dedicated, multidisciplinary, and diverse scientists that included several Jews, agnostics, and atheists, as well as Christians.
So not just believers, then?
Apparently not. The only criteria for recruitment was excellence in their field of knowledge. This really suggests Gove's worry about bias might have been, well, maybe misplaced, or at least an oversimplification of a group dedicated to science, whatever their personal views.
So the bigger issue wasn't just about belief, it was about the scientific approach itself, undermining the integrated plan.
That's the source's conclusion, that under Gove's leadership, the radiocarbon laboratories compromised the pursuit of the truth by undermining an important integrated, multidisciplinary testing program. That program would have provided crucial context, other data points to help interpret the C14 result.
Losing that context seems like a huge loss for the scientific process.
It really does. It set the stage for a single data point to be interpreted in isolation, which is often scientifically risky.
And the story gets even more complicated when you realize there were explicit warnings being sounded well before the test even happened, warnings that were just ignored.
Tragically ignored, yes. In March 1986, 2 full years before the C14 test happened without STURP's full plan, an archaeologist named William Meacham gave a paper.
From the University of Hong Kong.
That's him. And his paper, Radiocarbon Measurements in the Age of the Turin Shroud, Possibilities and Uncertainties, was incredibly prescient, almost like he saw what was coming.
What did he warn about?
He warned about what he called an unhealthy consensus building up. Almost a dogma, he felt, among C14 scientists and commentators, that dating the shroud would settle the issue once and for all.
That sounds overly confident.
Meacham thought so too. He argued this attitude sharply contradicts the general perspective of field archaeologists and geologists, people who actually deal with ancient, messy artifacts. They view contamination as incredibly complex.
Right, the difference between lab theory and field reality.
Exactly. C14 dating theory assumes the sample's carbon is only from when it was alive. Any other carbon is contamination.
And if that contamination has more C14 than the original sample,
it always makes the sample seem younger than it really is, unless you get rid of it completely. And Meacham knew from experience that standard cleaning often failed.
He gave examples, didn't he? Some pretty wild ones.
Really illustrative examples. Living snail shells dating to 26,000 years old. A freshly killed seal dated at 1,300 years old. 1-year-old leaves looking 400 years old.
A Viking horn dated to the future, 2006.
Bizarre, right? And maybe most relevant, Egyptian mummy wrappings dating 1,000 years younger than the mummy inside. All because of contamination issues standard methods couldn't fix.
These aren't small errors. They show how easily things can go wrong. So what were Meacham's specific warnings for the shroud, given its unique history?
Well, he hammered home STURP's point. For an artifact like the shroud, with known spatially non-uniform contamination, you must take multiple samples from different spots. It wasn't optional, in his view.
And the danger of just one sample?
He was clear. If you take just one sample, especially from a dodgy area where you can't remove contamination, the result is based on a single, possibly inaccurate measurement. It lacks unimpeachable scientific validity.
Basically, you can't trust it.
You can't be certain. He even said no responsible radiocarbon scientist would claim they'd removed all contaminants, and that a single sample's date range was definitely the object's true age. That's strong language.
He also flagged a specific area as problematic, didn't he? The Ray's sample zone.
Yes, he zeroed in on that corner. This was where Professor Gilbert Ray's took samples back in '73, and where Max Free took pollen samples.
Well, I was wrong with it.
Ray's found cotton mixed in with the linen there, which was weird because other parts of the shroud only had tiny traces of cotton, so right away it looked non-representative.
Not typical of the main cloth.
Exactly. But it wasn't just the cotton. Meacham pointed out other issues there. An old water stain, scorching marks from a past fire, and the fact it was likely used as a handhold for centuries when the shroud was displayed.
So accumulating grime and oils from hands.
Precisely. Layers of debris and unknown organic contamination. He explicitly said, do not cut samples from this area.
It sounds like a flashing red light.
It really does. And he didn't just warn about the where, but also the how. He insisted on multidisciplinary pretesting.
Before any C14 analysis.
Absolutely. Not just C14 folks, but a multidisciplinary team effort. Chemists, textile experts, archaeologists working together. He said, such consultation would certainly make very clear the danger of sampling an anomalous zone.
Combining expertise to avoid obvious pitfalls. Makes sense.
And finally, he recommended really advanced cleaning and preparation for any sample taken.
More than just a standard wash.
Way beyond standard. Elaborate pre-treatment, he called it. Using things like scanning electron microscopy, SEM, to see tiny impurities, microchemical tests, mass spectrometry, micro-Raman spectroscopy, really high-tech stuff to screen for any intrusive substances.
Like hydrocarbons, carbonates.
Yes, things that could carry extraneous carbon and mess up the date. He was basically calling for forensic-level care, recognizing the shroud wasn't just any old piece of cloth.
So these warnings were out there, clear as day. Yet we move into 1986, and the focus shifts to negotiating the Turin Protocol. Lots of debate about who's in charge, right? Vatican versus Turin.
Intense debate. Vigorous discussions, as the source calls it. Authority was a big sticking point. And also how many labs, how many samples, all being hashed out.
And eventually they held a meeting in Turin, September 86.
Yes, September 29th to October 1st. Chaired by Carlos Chagas, head of the Vatican's Pontifical Academy of Sciences. He assumed the Vatican would have ongoing oversight.
But Turin, as the custodians, felt differently.
They did. They believed they should control it, citing their history with the Shroud and the 78 STURP expedition. They insisted on inviting specific specialists.
Including some the C14 group apparently wanted to exclude.
Interestingly, yes. Despite efforts to keep them out, both Alan Adler, the STURP chemist, and William Meacham, the archaeologist with all the warnings, were invited and participated. That was apparently Turin's doing.
So what did this meeting agree on? What was in the Turin Protocol?
Some key agreements were made aimed at ensuring rigor. First, 7 labs were to be involved for statistical power, 5 AMS labs, 2 older small decay counter labs.
7 labs and samples.
7 samples, 1 for each lab, multiple independent measurements. That was crucial.
And the locations. Did they follow Meacham's advice on multiple spots?
Well, this is where it gets fuzzy. The final written protocol didn't specify exact locations, but at the meeting, Alan Adler clearly stated at least 3 different areas must be included. Meacham backed him up. Both thought that was the agreed consensus.
But that understanding didn't hold.
It proved incorrect, unfortunately. A major point of contention later on.
And the oversight issue wasn't resolved at the meeting either.
No. Afterwards, the Archbishop of Turin petitioned the Vatican, arguing his team should have sole oversight, not Chagas's academy. And Turin won. They got sole control.
And once they had control,
They unilaterally acted to modify the Turin Protocol without further consultation.
modify how?
Dramatically. They slashed the number of labs from 7 down to just 3, and only AMS labs, Oxford, Zurich, Arizona, the small decay counter labs were out.
Cutting the number of labs by more than half, that must have caused an uproar.
A huge uproar. All 7 original labs, including the 3 eventually chosen, vigorously protested these arbitrary changes. They were seriously concerned about the scientific validity.
Did they warn Turin directly?
They sent a formal letter to the Archbishop stating the changes may lead to failure, a pretty stark warning from the scientists involved.
And Harry Goes, who'd wanted the standalone test, he even drafted a letter to the Pope.
He did. Even more forceful. It basically said, this procedure's flawed, it won't give a reliable date, it will just cause controversy, maybe it's better not to date the Shroud at all. That shows how deep the concerns ran, even among the C14 proponents.
But that letter never got sent.
No, because the 3 labs that Turin had chosen, Oxford, Zurich, Arizona, wouldn't sign it, so the unified protest fell apart.
So the modified, scaled-down plan went ahead, despite all the scientific objections.
It seems so.
Right.
Administrative decisions overrode the scientific consensus at that point.
Which brings us to the actual sample cutting. April 21st, 1988, after all the warnings, protests, protocol changes, the day finally arrives, and the circumstances sound less than ideal.
Less than ideal is putting it mildly. The Turin authorities oversaw it. 2 qualified textile experts were invited to help.
But their qualifications were questioned.
Apparently, they had little or no expertise concerning the shroud specifically. Reportedly, it was the very first time they'd even seen the shroud.
Not exactly deep familiarity with the artifact's complexities then.
Hardly. Raises questions about whether they could recognize problematic areas.
And the sampling itself. After all the talk of multiple samples from different pre-analyzed spots.
It beggars belief, really. After 2 hours of debate just to pick the spot, they cut only one single sample.
One sample. And where did they cut it from?
Near the hem where the raised sample had been removed in 1973. Precisely the area Meacham had explicitly warned against, citing cotton contamination, water stains, scorching, handhold grime.
It's almost unbelievable they picked the one spot they were told not to pick.
It seems that way. A single sample from arguably the most questionable area on the entire cloth.
And the representatives from Oxford, Zurich, Arizona were there watching this. Did they object? Say anything?
There is no record of them making any objections. Not about the single location, not about the choice of that specific problematic location, which is striking given their earlier protests about protocol changes.
Silence at a critical moment. And the cleaning. Did they follow Meacham's call for elaborate pretreatment? SEM, mass spec, all that?
It appears not. The sources indicate the labs used their extensive but standard cleaning methods. There's no report they did the advanced microscopy or microchemical screening Meacham recommended for identifying unusual impurities.
So, standard cleaning for a non-standard, highly contaminated sample location.
That seems to be the case. A potential mismatch between the cleaning protocol and the sample's specific challenges.
Okay. So, flawed process, ignored warnings, questionable sample, and then the results drop. October 13th, 1988, Cardinal Ballestrero in Turin announces it. The world is watching.
A huge media event. And the result. The C14 tests gave an age for the shroud of 1260-1390 AD, 95% confidence, medieval.
And Oxford announced basically the same results simultaneously in the UK.
Yes, nearly identical results presented at the same time, reinforcing the conclusion. And then, published in Nature a few months later, February 89, seemed ironclad.
But looking back, how does that result square with all the warnings and procedural issues?
According to our sources, it doesn't square at all. The assessment is blunt. In the whole episode, every one of Meacham's warnings, along with similar warnings from the STURP team, as well as the core provisions of the Turin Protocol, were ignored. A total disregard for expert advice.
And Teddy Hall at Oxford, he seemed pretty triumphant about it.
Famously so, photographed by the blackboard with the date and that emphatic exclamation point, his quote was just devastatingly dismissive.
And what about forgery?
Yeah. There was a multi-million-pound business in making forgeries during the 14th century. Someone just bit a linen, faked it up, and flogged it. Just like that, case closed.
Exactly what Meacham warned no responsible radiocarbon scientist would say about a single sample.
Precisely. It was a moment of supreme confidence, perhaps overconfidence, that seemed to sweep aside all the complexities in prior research.
So the medieval day hits the headlines. Seems definitive. But the story doesn't end there. Questions started emerging, particularly about the samples themselves, right? Like the one Arizona had.
Yes. Years later, things started to surface. In 2010, the head of the Arizona lab co-authored a paper about a piece of their sample they'd kept. And they reported some strange details.
Like the thread counts.
Exactly. They reported warp thread count as 30, weft as 40, but other researchers, especially STURP's textile people, consistently reported the opposite for the main shroud body, a higher warp count than weft, typical of its specific herringbone weave.
That's a basic structural difference. Suggests the Arizona sample might not match the rest of the cloth.
It certainly raises that possibility. And there was also a thickness discrepancy.
What was that?
Arizona reported their sample as 250 micrometers thick. But John Jackson's STURP measurements, recorded by Ray Rogers, were consistently above 300 micrometers all over the shroud, often well above 300, not one measurement below 300.
Again, a significant physical difference.
It is. So the question becomes, was this just a measurement error by Arizona? Or maybe how they measured it? Or was their sample genuinely physically different from the main shroud cloth? If so, it definitely wasn't representative.
And beyond individual samples, people started looking closely at the statistics of the 1988 results across all three labs.
Yes, papers came out 1998, 2013, analyzing statistical oddities in the reported results. They weren't just random variations.
What did they find?
They found the discrepancies could be correlated to the linear location of the pieces cut from that single original strip. Remember, they cut one strip, then divided among the labs.
So the position along that strip mattered.
Apparently, yes, it showed a linear trend. Like one end of the strip consistently dated older, and the other end consistently dated younger. A gradient within the single sample.
That's wild. What does that imply statistically?
The conclusion was profound. Because the data was heterogeneous, not uniform, and showed this linear trend, the tests could not be considered as a repeated measurement of a single unknown. You can't average dates from a non-uniform sample and claim it represents the whole object accurately.
It fundamentally undermines the validity of treating that single 1260-1390 AD range as the date for the entire shroud.
That's exactly the implication of these statistical analyses. The sample itself seemed flawed or non-homogeneous.
Given all these issues with the C14 date, it's no surprise researchers started looking for completely different ways to date old linen, like that Italian study in 2015.
Right. They tried a different approach, entirely comparing chemical properties and fiber tensile strength. They compared alleged shroud fibers to control linens of known ages, modern to ancient.
Looking for age-related degradation patterns.
Kind of, yeah. How chemical structure and physical strength change over time.
And what date did they get?
Their result was intriguing. 372 AD, 400 years. Puts it right back in the historical time frame many associate with the shroud.
But this result isn't widely accepted yet. There are concerns.
It's not yet broadly endorsed, as the source puts it. The big challenge is the inherent difficulty of knowing the environmental conditions any old cloth has endured. Humidity, temperature, light, these things affect linen degradation dramatically, and we don't know the shroud's full environmental history.
So, different storage could give different results with this method.
Potentially, yes. It makes calibration very tricky. So while it's important research, it's still considered early stages, complex stuff, but definitely highlights the need for alternative dating methods.
Now, our source, TSC, uses strong language, calls the 1988 testing tragic. Why tragic?
It's tragic on multiple levels from their perspective. First, because it was a flawed scientific exercise in itself, given the ignored warnings and procedural shortcuts.
But also because of how it happened. Carved out of STURP's plan.
Exactly. That's maybe the bigger tragedy. It was isolated from STURP's integrated proposal and, crucially, done first. So none of that other vital contextual data, microbiological, spectroscopic, chemical, was available to help interpret the C14 result. It landed like a bombshell in a vacuum.
And the consequences of that bombshell.
Immediate and far-reaching. The source says everything changed. The custodians in Turin became uncertain about what they had. The medieval date seemed definitive to them.
And that uncertainty led them to
halt all other scientific examination. Just stopped it. None of the other 25 studies proposed by STURP in 1984 ever happened. The shroud became virtually inaccessible for scientific analysis ever since.
Wow. So the dating result actually shut down further science.
Ironically, yes. The priority shifted entirely to preservation, based on the assumption it was medieval. This led directly to the 2002 restoration project, which many researchers feel further complicated future scientific access.
But TSC, despite all this criticism, they do accept the basic C14 measurements, just not the final date interpretation.
That's the crucial distinction, yes. They accept the validity of the reported radiocarbon measurement. They presume the labs accurately measured the isotope ratio in the sample they were given. They trust the measurement integrity.
But they don't accept the 1260-1390 AD date as the shroud's true age.
Correct. They argue it doesn't represent the true calendar date age. Why? Because a whole complex of historic, archaeological, cultural, and scientific findings points elsewhere.
Like their own study of fold lines.
Exactly. Their analysis of fold patterns suggests a Byzantine history, centuries earlier than the C14 date. This broader evidence creates a conflict, suggesting the C14 result is an anomaly that needs explaining.
Which leads to the scientific imperative.
Not to just reject the result, but to continue to work diligently to show why it is anomalous, using sound scientific methodology. Understand the discrepancy. Don't just dismiss it.
And remarkably, years later, the head of the Oxford lab himself seemed to acknowledge this complexity. Christopher Ramsey, in 2008.
A really significant moment. Ramsey, who took over from Teddy Hall, made a statement that effectively erased the emphatic 1988 exclamation point. A real credit to him and the lab, showing scientific openness.
What did he say?
He acknowledged the conflict. He said, with the radiocarbon measurements and with all of the other evidence, there does seem to be a conflict. And for that reason, I think that everyone who has worked in this area need to have a critical look at the evidence in order for us to try to work out some kind of a coherent story that fits and tells us the truth.
That's a huge shift from faked it and flogged it.
A massive shift. An admission that the C14 result doesn't align with other evidence, and that more work is needed to find a coherent explanation. It reopened the scientific discussion, at least implicitly.
Okay, so if the data is anomalous, the next logical step is searching for the cause of the anomaly. This means challenging the basic assumptions of C14 dating, right?
Exactly. Any dating method relies on assumptions. For C14, there are three big ones. 1, the sample is representative of the whole thing. 2, no contamination messed with the C14 other than natural decay. 3, we know how much C14 the thing started with.
And if any of those are wrong for the Shroud sample,
The date could be wrong, and there's significant research challenging assumption number 1 that the sample was representative.
we mentioned the statistical issues, the linear trend, but there's chemical evidence too, from Ellen Adler.
Yes, Adler, the STURP chemist, found something chemically distinct about the C14 sample fibers.
What was it?
More salt, significantly more salt in the radiocarbon sample fibers than the water stains on the rest of the shroud.
Why would there be more salt just there?
He figured it was because the sample came from a bounded water stain. On the main cloth, stains could spread out, salts diffuse, but in that corner, maybe bounded by a seam or a fold or something, the water evaporated and the dissolved salts got concentrated right there at the edge.
Creating a localized chemical hotspot.
Precisely, leading Adler to conclude, the radiocarbon sample fibers have a different chemical composition, therefore, it is not a representative sample. Simple as that. The chemistry proves it's different.
Okay, so assumption #1 looks shaky. What about assumption? #2, no significant contamination. People have proposed contamination theories, like the reweave idea.
The reweave hypothesis is popular. It suggests the corner was patched up in the Middle Ages with younger linen, maybe after a fire. If the sample included this younger patch, boom, medieval date.
Makes intuitive sense, but is there evidence for it?
Well, some visual interpretations suggest repair, but critically, the textile experts involved in the 2002 restoration carefully examined that area and found no explicit evidence of reweaving.
And TSC looked at STURP's images too.
Yes, they studied STURP's X-rays and transmitted light photos of the area. Those techniques should reveal structural changes like a reweave. They found no evidence either, so TSC finds this negative evidence pretty compelling. Suggests the answer isn't a simple patch job.
Okay, if not reweaving, what about the bioplastic idea? Microbes leaving a coating.
The bioplastic contamination hypothesis. The idea is bacteria or fungi grew on the fibers over centuries, absorbed modern C14 from the air, died, and left a carbon-rich film. If not cleaned off, this has younger carbon.
Plausible. Why does TSC reject it as the main explanation?
It's a numbers game. To shift a first-century date all the way to the 14th century purely through this kind of contamination, you'd need a huge amount of it, almost doubling the sample's original mass.
Doubling the mass, that sounds like a lot.
It is. And TSC's own measurements show the C14 sample's mass per unit area is pretty similar to the rest of the shroud. There just isn't enough extra mass there to support the idea that bioplastic coating alone caused such a massive date shift.
So standard contamination theories don't quite cut it for TSC, which leads them to enhanced contamination hypotheses. This sounds more exotic.
It pushes the boundaries a bit, yeah. Looking for non-standard ways C14 levels could have been altered. Two main contenders here. First, the carbon monoxide CO hypothesis.
CO, not CO2. How does that work with C14?
This involves some newer understanding of atmospheric chemistry. C14 is made high up when cosmic rays hit nitrogen. Now, it turns out that new C14 doesn't immediately grab two oxygens to make CO2.
What does it do?
A predominant fraction grabs just one oxygen, forming carbon monoxide CO. And this CO takes a while, 30-60 days, to fully convert to CO2.
So there's C14-enriched CO floating around.
Exactly. CO found near the Earth's surface, especially near fires or pollution, is often highly enriched in radioactive C14 compared to background CO2. And CO is reactive. It likes to bond with things.
And John Jackson at TSC connected this to the Shroud.
Yes. Jackson hypothesized this enriched CO could be a significant source of contamination. And here's the kicker. Because this CO is so enriched, you wouldn't need much of it.
How much?
His calculations suggested only about 2% extra carbon relative to the sample's total carbon from this enriched CO would be enough to shift a first-century date to the 14th century.
Just 2%. That's tiny.
Tiny, Potentially undetectable by standard mass checks, but enough to drastically skew the date because its C14 concentration is so high, makes it a very elegant potential explanation.
Has TSC done experiments on this?
They have, exploring how linen might absorb this CO. Jackson even discussed preliminary results with Christopher Ramsey at Oxford back in 2008, and that discussion contributed to Ramsey making his statement acknowledging the complexities. So it's being taken seriously.
Okay, that's one enhanced idea. What's the second? The neutron flux hypothesis. Sounds intense.
It does, and it came from a letter in Nature, same issue as the C14 results, by Thomas Phillips from Harvard High Energy Physics. He proposed the shroud might be fundamentally altered regarding C14.
Altered how?
Possibly by witnessing some unexplained event, possibly in the tomb of Jesus. Now, Phillips was clear. The event itself is beyond science, but its effects might be testable.
What effect did he propose?
That the event generated a burst, a flux of neutrons. These neutrons could have slammed into the linen, converting some stable nitrogen N14 atoms within the fibers directly into C14.
Creating new C14 right there in the cloth.
Exactly. Artificially adding C14, making the cloth seem much younger than it is.
That's a radical idea. Is there any way to test it?
Phillips proposed one. He argued that such a neutron burst should also create other unstable isotopes, not just C14. Some of these might have half-lives long enough to still be detectable today, but short enough not to occur naturally. Finding these specific unnatural isotopes on the shroud would be evidence for a past neutron event.
So searching for these unique isotopes could support or refute the hypothesis.
Precisely. It's a fruitful line of research, as Phillips put it. And TSC notes other researchers, like the Antonacci team, are actively looking for such isotopes. It's a fascinating, if challenging, avenue.
So wrapping this all up, where does this leave us? We have this 1988 C14 result, 1260-1390 AD. The measurement itself is probably accurate for the sample tested.
Right. The labs likely measured the C14-C12 ratio correctly in that specific piece of linen.
But the massive question remains, does that measurement actually tell us the age of the entire shroud?
And based on everything we've discussed, the sample representativeness issues, the ignored contamination warnings, the statistical anomalies, the conflicting evidence from history, archaeology, other science, and these potential enhanced C14 mechanisms, our source, TSC, concludes no.
They don't accept the 1988 date as the shroud's true calendar age.
Not even as an approximation. The specific reason why the result is anomalous is still unknown. Could be CO, could be neutrons, could be something else entirely. But the consensus here is that the 14th century date doesn't fit the overall picture.
Which leads to the scientific call to action.
Keep digging, keep researching, not to simply reject the C14 result, but to diligently work to understand it. Why did that specific sample yield that specific date? Figure out the anomaly using prudent, correct scientific methodology.
And this is where it gets really interesting for you, the listener. Until and unless the specific cause for this anomalous date is scientifically understood and rigorously demonstrated, the strong recommendation from our source is
that the scientific community and the public not push for another round of radiocarbon testing. Doing the same test again without understanding why the first one gave a potentially skewed result might just repeat the confusion.
It's a living example of science grappling with complexity, isn't it? The challenges, the setbacks, the ongoing pursuit of truth.
Absolutely. So the provocative thought for you is, which lines of research, maybe the enhanced contamination ideas, maybe alternative dating methods, maybe something else entirely, do you think hold the most promise for finally unraveling this persistent, fascinating mystery? And how do we make sure future research avoids the pitfalls that plagued the 1988 dating?